Welcome to MathStuber. So in the last video, we have done till the 10th question of the third exercise, sorry. So we will continue with this. We were discussing variable separable method in the last video, and let's start with the 11th question where we are given with the values of x and y to find a particular solution. So the method will be the same. It's just that we have to solve it for the value of c as well, right? So the question is x cube, 11th question is x cube plus x square plus x plus 1 into dy by dx is equal to 2x square plus x. And the values given are y equal to 1 when x equal to 0. So these are the values given. So first of all, we have to separate the variables from this, and then we have to integrate both the sides. And after integrating both the sides, we have to find the value of c, that is the constant of integration. So first of all, we can take out x square common from these two. So you'll get x plus 1. And from the other two, you can take 1 common because there is nothing common in it. So this will be now this can be written as x into 2x plus 1, right? X is common from both the terms. Now, if we take x plus 1 common, you will get x square plus 1 dy by dx, which is equal to x into 2x plus 1. Now, as we discussed, we have to take all the same variables to one side, and we have to take dy and dx to uh, the sides where if x is if the variable x is on one place, we have to take dx to that side only. So we'll take dy, means we will keep dy here, and we'll take dx here, and other things also on the right hand side will shift it. So it will be x upon 2x plus 1, x into 2x plus 1 upon x plus 1 into x square plus 1 dx. And then integrating both the sides, right? Now, as you can see here, we have these terms. So how can we integrate this kind of thing? We can integrate it by using the partial fractions. So we will first have to take this whole term of x and convert it into partial fractions. So x into 2x plus 1 divided by x plus 1 into x square plus 1, which will be equal to a upon x plus 1 plus, because this is a quadratic, so we have to take bx plus c upon x square plus 1, right? Now taking the LCM here, we will get x upon 2x plus 1, x into 2x plus 1 upon x plus 1 into x square plus 1. It will be equal to a into x square plus 1 plus bx plus c into x plus 1 divided by x plus 1 into x square plus 1. So you can see this whole will be cancelled, and you will get 2x square plus x equal to ax square plus a plus bx square plus bx plus cx plus c. Now taking common as per the coefficients, means as per the power of x, we will get a plus b into x square plus b plus c into x plus a plus c. Right. So we have so now we can compare these coefficients. Now x square's coefficient here is 2 and this is a plus b. So a plus b is equal to 2. The coefficient of x on both the side will be equal. So b plus c will be equal to 1. And because there is no constant term on the left hand side, so it will be equal to 0. A plus c will be equal to 0. And now we have to calculate the values of a, b, c from here, right? So we have to, so from this equation a plus c, we'll take c is equal to minus a. And we will put this c equal to minus a in the second equation. Here, we'll put it here. So you will get b minus a is equal to 1. And solving it with the first equation, that is a plus b equal to 2. So minus a and a will get cancelled. You will get 2b equal to 3, b equal to 3 by 2, right? So if b is equal to 3 by 2, then um, put it in the first equation, that is a plus 3 by 2 equal to 2. A is equal to 2 minus 3 by 2, that is 1 by 2. And c will be equal to minus 1 by 2 because it was equal to minus a. So here we got the values for A, B, and C, all three. And now we can put it in the first equation. So it will be integration of integration dy into integration of 1 by 2 upon x plus 1 plus 3 by 2 x minus 1 by 2 upon x square plus 1 dx. Right. Now dy integration is half integration of 1 upon x plus 1 dx plus we'll convert all these x upon x square plus 1 dx, and this will be minus 1 by 2 1 upon x square plus 1 dx. So now for this second one, we can substitute the values, put x square plus 1 equal to t, so that it will become 2x dx equal to dt. So here we need 2. So if we multiply 2 here, we have to divide this by 2 also, so that we can substitute it. And now we can integrate the whole thing. This will be y equal to half of log of x plus 1 mod plus 3 by 4. This will be dt upon t, right? So dt upon t is log of mod t minus half of 1 upon x square plus 1 is tan inverse x upon 1, that is tan inverse x only, and plus c. So this is the answer. Now just substitute the value of t here. Log of x plus 1 plus 3 by 4 log of x square plus 1 minus half tan inverse x plus c. Now to find out the value of c here, we have to substitute the values of x and y which were given in the starting. Y equal to 1 when x equal to 0. So we will substitute the values here. We have to substitute x equal to 0 and y equal to 1. So now uh, y equal to 1 when x equal to 0. So 1 will be equal to half of log 1 plus 3 by 4 log of 1 minus half of tan inverse 0 plus c. Now, as you can see, log 1 is always 0, right? So this will be 0, this will also be 0, and tan inverse 0 is also, I think, 0 only. Tan 0 is 0. So you can see C will be equal to 1 from here. Therefore, the equation will be given by half of log x plus 1. We will substitute the value of C in the equation only that we got. 3 by 4 log of x square plus 1 minus half tan inverse x plus 1. And this will be the final equation. So that's it. The procedure is the same. It's just that the last step is to find out the value of C and substituting again the value of C in the given equation, means in the equation that we have found out, right? So that is all. Next is, let us do one more question related to this. So let's do this 13th question. So it is given cos dy by dx is equal to a, where a is a real number, a belongs to real number, and the given condition is y equal to 1 when x equal to 0. So that is the same thing given. Now we have to separate this dy by dx first. So we can take this cos to the other side. It will become cos inverse a. And we know that cos inverse a is a constant. So we just have to separate the dy and dx here. So we can take this dx to the other side and integrate both the side. You will get y. Cos inverse a will be as it is, and the integration of dx is x plus c. Now, y equal to 1 when x equal to 0. So we'll substitute the values here. 1 equal to cos inverse a into 0 plus c. C will also be equal to 1. Therefore, the equation is given by x cos inverse a plus 1. And that is the final equation. Right? So that's a simple question. I hope this is clear. Now, let us move to the questions. Uh, these questions from 15 to 22, these are never asked in the board examinations. So we can skip these, but still they are very easy questions. So let us try the last question of this exercise, 23rd question, which is a multiple choice question. We have to find the general solution for dy by dx equal to e raised to power x plus y. So now, how to separate it? We can separate this e raised to power x plus y as e raised to power x into e raised to power y. And then just separate them. E raised to power dy upon e raised to power y is equal to e raised to power x into dx. And we can just take this e raised to power y as in the numerator as e raised to power minus y, right? So integrating both the sides, e raised to power minus y dy is equal to e raised to power x dx. Integrating both the sides now, you will get minus e raised to power minus y is equal to e raised to power x plus c. And if we take this, so we have to match the answer as well. So what we can do is we can take this C as C1 for now. And if we take this e raised to power minus y to the other side and C1 to this side, you will get e raised to power x plus e raised to power minus y is equal to minus C1. And this minus C1 can be written as capital C, right? Because we can adjust the this negative sign or any other constant multiplied or adding with C1 as C only. So this will be your answer, and I think this is the option number first only. A option is the right. I hope this is clear. Now let us continue with the next question. No, next topic, which is the second topic here. First was variable separable method. And now, if we are not able to separate the variables, then the second form of differential equation is known as homogeneous differential equations. Homogeneous differential equations, uh, as the name suggests, homogeneous here means uh, the power of the variables will be the same both the sides on LHS and RHS. So it will become a homogeneous equation. If the power of suppose a variable is 2 on the right hand side, then it will be 2 on the left hand side also. So this is known as homogeneous differential equation. For example, we can take an example here. X square dy by dx plus xy equal to y square. So here you can see the power of x is 2. The power of combined x and y is 1 plus 1, that is 2 because they are multiplied, so we can add the powers. And here also this is y squared, so the power is 2. Right? So overall, in the whole equation, the power is 2 for the variables, right? For every term, you can say. Now, how to do this question? So in this question, what we have to do is we have to change this complete um differential equation in the form of y by x or x by y, right? If dy by dx is given, if dy by dx is given, then change the equation to y by x. And if in the equation it is given dx upon dy somehow, then we will change the equation to x upon y. And sometimes uh, the equation is already converted into y by x or x by y form. So we don't have to do that step, right? If it is given x upon y, then we have to change x by y in particular form, and then we will change it. So what is the substitution that we have to do? First of all, we have to change it into y by x. If we want to change it into y by x, we have to divide it by x or x square or something like that, whatever is the power of the variables in the whole equation, right? And similarly, if we want to change it into x upon y, then we will have to divide it by y or y square or any other power which is there in the equation, right? So now, after changing it into x upon y or y upon x, we have to substitute that y upon x or x upon y equal to v. So y is equal to vx, and now we will just differentiate it. So we will apply the uh, product rule here. It will become v as it is, x ka derivative is 1, and plus x as it is, the derivative of v is dv upon dx. This we have to substitute in place of dy by dx. Or if x upon y is there in the equation, then also we will have to do it in this form. This will become Vy, and now we have to do dx upon dy. It will become V plus y dv upon dy because we are uh, doing it in the form of means in the with respect to the variable y. So these both we have to substitute according to the equation, right? And then after that, the third step is to separate the variable. So variable separable will be applicable here, but after doing these steps, right? So let us uh, try the questions. We will be able to understand better by solving the questions. From exercise 9.4, we will try a few questions. Exercise 9.4, the first question here is x square plus xy into dy is equal to x square plus y square into dx. So first of all, we have to either make dy by dx or dx upon dy, but it is always better to have dy by dx. It is much familiar. So we will take this dx because it is multiplied here. So we can take this dx to the right left hand side, and here you will get x square plus y square. So now first of all you have to understand the equation. Which type of equation is this? Whether the variables can be separated here or not, and if not, the powers of all the terms is the same or not. So obviously variables cannot be separated because dy by dx is multiplied to x square also and xy also. So if you want, you can try to separate the variables, but you will not be able to do it. Now you can see the second step is to find whether all the terms having the same power or not. So x square is having means x is having two power. Xy, I told you that if xy is there, then you can add their powers. So 1 plus 1 will become 2. Here it is x square, here it is y square. So all the terms are having two power, which means it is a homogeneous equation. Now we will have to divide by x square, right? Because the power is 2 for all. So we have to divide all the terms by x square. So it will become 1 y by x by xy upon x square will become y by x, dy by dx is equal to 1 plus y upon x square. So now the whole equation is converted into y by x form. And as I told you, after converting it, we have to put y by x is equal to v, y is equal to vx, dy by dx is equal to v plus x dv by dx. And then substitute all the values. So it will become 1 plus v into v plus x dv by dx plus, oh sorry, equal to 1 plus v square, right? Then multiply the whole equation here. V into 1 plus v, we will take v as it is here. Then, no, you have to just open it first. So it will become, if you multiply v with 1 plus v plus v square will be the answer. Then x 1 plus v, you don't have to multiply this one. You can separate it later. 1 plus v square. So you can see v square will get cancelled on both the sides, right? Then we will take this v to the other side, right hand side. We'll shift it to the right hand side. You will get x 1 plus v dv by dx is equal to 1 minus v. Now you can separate the variables easily. 1 plus v upon 1 minus v dv is equal to dx upon x. And now integrate both the sides. So now it will be much easier to integrate these. So what we can do is we can separate the variables here. 1 upon 1 minus v integration plus v upon 1 minus v dv, right, is equal to dx upon x. So now we have to just make it according to the given thing. So we'll take because there is 1 minus v in the denominator, so we'll have to make 1 minus v here also. So if we want, we can take minus v here, and minus 1 will be multiplied outside as well. And then adding 1 both the sides and subtracting 1 means adding 1 and subtracting 1 in this particular thing. 1 upon v dv minus integration of 1 minus v upon 1 minus v dv and plus 1 upon 1 minus v dv is equal to dx upon x. So yeah, this will get cancelled. This will become 1 dv. And you can see 1 upon 1 minus v, 1 upon 1 minus v, there are two terms of the same kind. So we can take it as 2 into I'll do it here only. You will get 2 into 1 upon 1 minus v dv minus 1 dv is equal to dx upon x. So this will be 2 log 1 minus v, and 1 minus v, the differentiation of 1 minus v is in the denominator, so it is minus 1 only. Then v is equal to log x plus c, right? Then just put the value of v, 1 minus y upon x mod y upon x is equal to log x plus c. And that will be the answer, right? So this is how we have to do it. Now let's do a few more questions from this exercise. So here, let us try the question. Uh, let's try the second question only here. Y dash equal to x plus y upon x. So first of all, you can see you cannot separate the variables. First of all, we'll write dy by dx here, and x plus y upon x you can write. If we want to separate the variables here, I don't think we will be able to do it, because if we cross multiply them, dx will be with the x will be with the dy, and dx will be with the y also. So now we can just check for the second thing, that whether all the terms are having the same power. So you can see the numerator is having 1 and 1 power x and y, and the denominator is also having 1 power. So yes, we can do that. So you can separate this x with both x and y, right? We can just break the LCM. So this will become x upon x plus y upon x, that is 1 plus y upon x. And this is dy by dx. Now put, as I told you, y by x equal to v. This will become y is equal to vx, dy is equal to dy by dx is equal to v plus x dv upon dx. So now if we put it in this equation, x v plus x dv by dx is equal to 1 plus v. And you can see v can be cancelled here. You are now left with x dv by dx is equal to 1. And if we separate the variables now, you will get this dv equal to dx upon x. Now integrate both the sides, you will get v equal to log of x plus c. And the value of v is y upon x, so we will substitute it and you will get the answer. You can multiply this to the other side, you will get log x plus cx, right? So this will be your answer. I hope this is clear. Now let us move to the next question. Let us do the sixth question now. So sixth question is x dy minus y dx equal to under root of x square plus y square. Here, uh, the variable separable method is not applicable because we will not be able to separate the variables, right? And if we are not able to do that, we have to check whether the powers of all the terms is the same or not. So the power of x here is 1, the power of y here is 1, but here the power of x square and y square is means x and y is 2. But there is also square root on both of these. So we can say that the square root of the square is only 1, right? So we can conclude that the powers here is the same for all the terms. So we will have to first divide all the equations by x. So this will become x dy by x dy upon x. So x will get cancelled. Minus y upon x dx under root of x square plus y square upon x. Dy minus y upon x dx is equal to. Now we have to take this x inside the square root. So you'll get x square upon x square, that is 1, and y upon x whole square is this, right? Now we have converted whole of the equation and we have to take this dx also, and there was dx here also. So we have to divide the whole equation by dx also. So dy by dx, because we have to make dy by dx here, and this will become 1 plus y upon x whole square. Now again we have to put y upon x equal to v. So it will become y is equal to vx, dy upon dx is equal to v plus x dv by dx, and the final equation will be v plus x dv by dx minus v equal to under root of 1 plus v square. V will get cancelled here. This will become x dv by dx is equal to under root of 1 plus v square. So now we can easily separate the variables. Dv upon under root of 1 plus v square equal to dx upon x, right? So v on one side and x on other side. And now we can easily integrate both of these. So 1 upon under root 1 plus v square is log of v plus under root 1 plus v square mod is equal to log x plus c. And I told you that if log is on every term, then you can take this as log c also. So it will become log of y by x plus under root 1 plus y square upon x square is equal to log of xc. And log will cancel on both the side. You will get y upon x plus x square plus y square under root upon x is equal to xc. And multiply the whole equation by x. So you'll get x square into c. And this will be the final equation, right? So this is how we can do the question. Now, in the seventh question, you can see that y by x is already given in the whole equation. But we have to first convert other terms into y by x. Like I'll do the seventh question also. So here you are given with x cos y by x plus y sin y by x whole y into dx is equal to y sin y by x minus x cos y by x whole dy, right? Whole x dy, sorry. So now, first of all, multiply this y to every term and similarly multiply this x to every term. You'll get xy cos y by x plus y square sin y by x whole dx is equal to xy sin y by x minus x square cos y by x into dy. And now, as you can see, uh, y by x is there in sine and cos, inside sine and cos, but we have xy and y square also. So we know that if y upon x is already given in the question, we will have to divide it by something, either x or x square, to convert other terms into y by x. So as you can see in every term, the power of the variables is 2, right? Xy power is 2, y square is 2. So every term is having power 2. So we will divide it by x square. So xy upon x square. And also we will divide the whole term by dx also to remove this dx from here and convert it into dy by dx. So you'll get cos y by x plus y square upon x square sin y by x is equal to xy upon x square sin y by x minus x square upon x square cos y by x into dy by dx. So this is how we have to do it. And now if we cancel these, you will get y by x cos y by x plus y upon x square sin y by x is equal to y by x sin y by x minus cos y by x into dy by dx. And now we will put this y by x as v. So put y by x equal to v, y is equal to vx, then dy by dx is equal to v plus x dv by dx. And then substitute this value here, you will get v cos v, v cos v plus v square sin v equal to v sin v plus cos v into v plus x dv by dx. And then separate all these terms. You will get v square sin v plus v cos v is equal to, sorry, plus v sin v plus cos v into x square into x dv by dx, right? V square sine v will cancel, v cos v will also cancel, and you are given with this only. I hope this is fine. Okay, this was minus actually. Here, this one is minus. So I think this will not cancel out, and this will also be minus. So this is minus, this is minus, this is minus. So if we take this v cos v to the other side, you will get 2v cos v equal to v sin v minus cos v into x dv by dx, right? Now we have to separate all the variables. So here you will get dx upon x is equal to dx upon x, 2 into dx upon x is equal to v plus v sin v minus cos v minus cos v divided by v cos v dv. So we have now separated all the variables here. Now this will be 2 into dx upon x is equal to, if we separate this LCM also here, you will get tan v minus 1 upon v dv. Will So now this is 2 log x mod, and the integration of tan v is log of sec v minus log of v plus log c, as the whole equation is in a log. So we can do this. So this 2 can also be taken as the power of x here. So you will get log of x square is equal to log of c sec v upon v. Log will cancel all these, and you will get x square equal to c into sec y by x upon y by x. So if we take this y by x to the other side, you will get xy only, because x will cancel out each other. And this is xy into c sec y by x. And this will be the answer, right? This is how we have to do these questions. Now let's try one question based on x upon y also, which is the 10th question. So 10th question, in the 10th question, 1 plus e raised to power x upon y dx plus e raised to power x upon y, 1 plus 1 minus 1 minus x upon y dx is equal to 0. So now we have to, as the whole equation is already in x upon y form, so we can put this as v. Put x upon y as v. X is equal to vy, and dx upon dy is equal to, and first of all, we we have to convert it into dx upon dy form before putting x upon y as v. So I'll just erase this step. So we will divide the whole equation by dy. So it will be 1 plus e raised to power x upon y dx upon dy plus e raised to power x upon y 1 minus x upon y, and this dy upon dy will become 1. So now we can put x upon y as v. X is equal to vy. Dx upon dy is equal to v plus dy upon dv. Dv upon dy. Y into dv upon dy. Right. So substitute the value. It will be 1 plus e raised to power v, 1 plus e raised to power v into v plus y dv upon dy is equal to, sorry, it will be plus e raised to power v into 1 minus v plus e raised to power v into 1 minus v is equal to 0. And if we multiply them, you'll get v plus v e raised to power v plus y into 1 plus e raised to power v dv upon dy is equal to, sorry, plus e raised to power v minus v raised to power v equal to 0. V raised to power v can get cancelled, and take this v and e raised to power v to the other side so that we can separate the variables here. So it will be minus v minus e raised to power v. And now we can separate the variables easily. Um, 1 plus e raised to power v upon v plus e raised to power v. As we can take minus common from here, you will get minus dy upon y, and integrating both the sides here. So now you can see the denominator in this step is actually means the numerator in this step is actually the differentiation of the denominator, right? So we can put v plus e raised to power v as t. So put v plus e raised to power v as t. You will get 1 plus e raised to power v into dv is equal to dt. So here you will get dt upon t is equal to minus of dy upon y. So log of mod t is equal to minus log of y plus c. And this will be, and you can write it as log c also. So log t plus log y is equal to log c, which is log of ty is equal to log of c. So ty will be equal to c. T will be v plus e raised to power v into y is equal to c. And this will be y upon x plus e raised to power y upon x into y is equal to c. And this will be the answer. Right. So this is how we have to do the questions. And after this, we have to, from 11 to 15 question, we have to find the particular solutions. And in the particular solutions, we have to just find out the value of c at the last, as we have done in the starting of this session. Right. So I'll do one question from this exercise for that. So let us try the 15th question for particular solution. You can try the rest of the parts. 2xy plus y square minus 2x square dy by dx is equal to 0. And here the given condition is y equal to 2 when x equal to 1. Right? So that we have to substitute at the last when we solve the equations. So you can see all the equations are having, means all the terms are having the power 2. So we have to divide the whole term by x square. So 2xy upon x square plus y upon x whole square minus 2x square upon x square into dy by dx equal to 0. So you will get 2y by x plus y by x whole square minus 2 dy by dx is equal to 0. So now put y by x is equal to t. Y is equal, sorry, not t, v. It will be vx and dy by dx will be equal to v plus x dv by dx. And then substitute it here. 2v plus v square 2v plus v square minus 2 into v plus x dv by dx is equal to 0. So 2v plus v square minus 2v minus 2x dv by dx equal to 0. 2v will get cancelled and v square equal to 2x dv upon dx. So now you can separate the variables here 2 into dv upon v square and then integrating both the sides. So log x equal to 2 into it will be v raised to power minus 3 upon minus 3 plus c. So you will get log x equal to minus 2 upon 3v cube plus c. And this will be log x equal to minus 2 upon 3 y upon x whole cube. That will become x upon y whole cube plus c. And now you can just put the values y equal to 2 when x equal to 1 to find out the value of c from here. So log 1 equal to minus 2 upon 3, 1 upon 2 whole cube plus c. Log 1 is 0 as we already know. So it will become 0 equal to minus 2 upon 3 into 1 upon 8 plus c. This will get cancelled and you will get minus 1 upon 12 is equal to c plus c equal to 0. C will be equal to 1 upon 12, right? And then substitute it in the equation. So you will get y, no, sorry, log x equal to log x equal to minus 2 upon 3 x upon y whole cube plus 1 by 12. And this will be the final answer, right? So this is how we have to do the questions for homogeneous differential equation. And in the 16th question, you can see a homogeneous differential equation of the form dx upon dy is equal to h x upon y. When x upon y is given, you have to substitute x upon y as v, and that will be x is equal to vy, right? And for that, which is the correct option? It is the C option that is correct. And then in the 17th question, this is also multiple choice. We have to tell which one of these is the homogeneous differential equation. So we just have to check the powers of all the variables. So in the first one, the power of all the variables means all the terms, not all the variables, all the terms should be the same. So in the A part, it is not same because 5 and 4 में तो कोई variable ही नहीं है. B part में also एक में square है बाकी में cube है. C is the correct option because x square है. No, x cube है. Sorry, C is not also the correct option. So the remaining is D. D is the correct option because all of them are having two power, right? In the 17th question. So in the next video, we will discuss the last um, solution of the differential equation by using the linear differential equations method, right? And we have completed two such uh, methods. So we'll continue with this in the next class. Till then, take care.